Hi there, everybody. This is lesson 3.2.5 about determining whether triangles are similar or not. We're going to get some flowchart practice today. And really, what making these flowcharts for triangle similarity comes down to one thing, really. And it's, do we use side, 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 angle, angle, or side, angle, side similarity? That is the big question. There's only three that work for showing triangles are similar. We saw yesterday that angle, angle, angle is too much information. Side, side angle doesn't work. There's lots of them that didn't work. But these are the three that do work. Okay, so really doing these flowcharts comes down to correctly picking one of those. So let's take a look at these triangles here and see which one we should use. So for side, 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 we would need to be able to check all three pairs of sides, all three pairs of side ratios, to use side, side, side similarity. So do we know all the sides in those two triangles? Could we find them if we needed to? Well, we don't know this side, and we don't know this side. The only way we can find a missing side right now is using the Pythagorean theorem. That only works for right triangles, so we don't have any right triangles here. At least it doesn't look like it's right triangle. So we don't have any way of finding this side or this side, so that means we can't check that ratio. So side, side, side isn't going to work here because we don't have enough information to use it. We need all the sides. We don't have it. What about angle, angle? For angle, angle, we need two pairs of angles that are the same. Well, we have one pair of angles that are the same, but we don't have any information about these other angles, angle K and angle M, angle A and angle C. And right now, we don't have any way to find those missing angles. Again, we will later in the course, but right now we don't. So we can't use angle, angle either because we only have one pair of angles and we need two. So side, angle, side is going to be the only thing we can use. And we can kind of check here. We've got an angle between two sides in this triangle. We've got an angle between two sides in this triangle. That pretty much says side, angle, side. So that is going to be our plan. Side, angle, side. Now, anytime in your plan that you see a side, you're going to check a ratio. So for this part of the plan, we got to check a side ratio. Let's take 3. Which side over here corresponds to 3? Well, 3 is the smaller of those two, so we're going to take the smaller of those two. That's 6. So let's do 3 over 6. You know what? I've been doing small over big in these videos. Let's do it the other way. Really, it doesn't matter as long as you're consistent. So 6 over 3 is 2. So far, so good. Now, this side over here, again, is another ratio we got to check. We haven't used 8 yet. 8's the bigger of these two sides. 16 is the bigger of these two, so 8 and 16 are going to go together. Now, I did big over small here, so I have to do big over small here. And looky there, those two give us the same ratio. But we're not done yet. We have not filled out our plan completely. We've got a pair of angles here. Anytime you see an A in your plan, you have to have a pair of angles that are the same. So we have a pair of angles that are the same, B and L. Measure of angle B, I ran out of room here, equals the measure of angle L. That's a weird way to write that because I just didn't have enough room to write it all in one line. You know what, I'm just gonna move it down. Let's do that. Measure of angle B equals measure of angle L. Now, it's really, really important for side, angle, side that the angles in the triangles are between the two sides you're checking. Okay, if it's not between the two sides, then you've got angle side, side, and as we saw yesterday, that doesn't work. Neither does side, side angle. But if the angle is between the sides in both triangles, as it is here, then side, angle, side is okay to use. And we are finished with our plan here. We've got two pairs of sides that give us the same ratio. We got one pair of angles that are the same. That's what we needed. We are ready to say that these triangles are similar. Let's call this triangle BAC. Doesn't matter what you call the first one, but the points in the other triangle have to go in the same order. See, I started with B, and that's the 40-degree angle here. So that means I got to start with L on that one. L. A, let's see. A is the one that's opposite the bigger side. This angle and this side are opposite each other. Here's the bigger side. So the angle that's opposite that is the K. So K will go next. C is the only one that's left. Let's see, I got L and K, so M is the only one that's left. So that's going to go there. And there we've said that those triangles are similar. Now arrows. We used each of these three statements to show that those triangles were similar. So we've got to have some arrows going from those three bubbles to that last one. Are we done? I hope you're screaming no. Maybe not screaming, but I hope you're saying no, because we have to justify this last statement. It's the only one we have to justify at this point. All the other information is just given to us in the picture. That's why we're not just really justifying it now. But we do need to justify this. And remember that what we write here is pretty much the same as the plan. The only difference is that in the plan we don't bother with the similar symbol, but that similar symbol is important. Later in the course we'll prove that triangles are congruent, and then we'll use side angle side with a different symbol here instead of the similar symbol. So again, don't omit the symbol. Make sure you put that similarity there. And there is our flow chart. That is a convincing argument for why those two triangles are similar. That's it for today. Hope you guys have a great evening. We'll see you soon. Bye.